All right, welcome. We're going to talk a little bit about what an inequality is. Okay, this is the question that we're going to answer right now, and these are inequality symbols. Now, you know what an equal symbol is. It states that two expressions are equal to one another. Well, an inequality symbol denotes how two expressions are related to one another. They may or may not be equal. So here's how this works. This symbol right here is called the greater than symbol. Let me show you how to read this. I read it just like a book. Okay, greater than. So for instance, I would say 6 is greater than 3. And that looks pretty intuitive. It's pretty straightforward. Now, why is it greater than? Well, look, the opening on this particular symbol, right here on the left, this part is greater than this part. Okay, so if I'm looking from left to right, this is greater than this. Now, some people like to use the alligator, and this side has to be bigger than that side, or the Pac-Man, and that's fine. If that works for you, by all means, go for it. This is just another way to kind of think about the greater than and less than symbol. So let's look at that less than symbol. This is less than. Less than faces the opposite way. And it says that the number on this side is less than the number on this side. Why? Well, the opening on this left side is less than the opening on this side. It's smaller here than it is here. So the phrase greater than or less than, you could say it strictly comes from the shape of the symbol that we're talking about. Okay. So what about the greater than or equal to? And I'm going to get into what that means later, but you have those as inequalities as well. All right. This is the not equal symbol. It strictly means that two quantities are not equal. So if I were to solve this equation and I came up with something like 0 equals 4, I know that's absolutely not true. So I'd say that's not equal. All right? What we're going to do is I'm going to show you the difference between an equation and an inequality and how to solve them. They're very, very similar. And there's a couple major differences, and we'll address that right now. All right, so here's the equation. I'm going to finish this one out in a darker color. We're solving this equation. Solve it just like you normally would. Here's negative 3x. So we're going to add it to both sides and try to get all our x's on one side of our equation. So I get 13 plus 4x equals 5. And then minus 3x plus 3x, that gives me 0. All right, well, we're going to subtract 13 from both sides of our equation, and I end up with 4x equals negative 8. And then divide both of these sides by 4. You get x equals negative 2. Now, what does that mean? That means negative 2 is the only number I can plug into this equation and get a true statement. So what does that look like? I'll show you. So let's try it. Let's plug it back in. So I'm going to plug in negative 2. Watch this. I got 13 plus negative 2. So everywhere I see x, I'm putting in negative 2 equals 5 minus 3 times negative 2. Let's simplify it. So 13 plus negative 2 is 11. 5 minus 3, but times negative 2, that's 5 plus 6. Which equals 11. So this is a true statement. 11 is 11. If I plugged any other number in there, I would not get a true statement. This would be something like 14 equals 10, and that is not true. So we're going to solve this inequality. I'm going to show you the steps that we go through for that one. And we're going to continue to do this in blue. It's already in blue, so let's do it in blue. All right, just like we did over here, it's almost the same steps. We're going to add 3x to both sides. Now, if you decided, hey, I'd rather subtract x to from both sides, or I'd rather subtract 5 from both sides first, by all means, that's still solving the equation or inequality. You might get something slightly different on this, but the meaning will be preserved, and I'll show you how to interpret that in another time. So we're going to add 3x to both sides. You get 13 plus 4x is greater than or equal to 5, and this becomes 0. All right, let's continue. Let's subtract 13 from both sides, just like we did over here. and we end up with 4x is greater than or equal to negative 8. All right, well, right here we're going to divide by 4 just like we did before. 4 divided by 4 is 1. 1 times x is greater than or equal to negative 2. Okay? So here, negative 2 is the only answer that works in this equation to make a true statement. For an inequality, it's much different. X can be any number that is greater than or equal to negative 2. So let's choose a couple. If I substitute negative 2 into this inequality, you end up with something like this. 13 plus negative 2 is greater than or equal to 5 minus 3 times negative 2. And notice that these two are almost identical except for that inequality symbol. And simplifying it works almost the exact same way. You get 11 is greater than or equal to 11. Is that a true statement? It is, because 11 is greater than or equal to 11. It's equal to itself. So this is a true statement. Let's try another number. Let's pick something else, something that's bigger than negative 2. All right, let's pick something that's bigger than negative 2. How about negative 1? Or 0. 0 is a nice number. 0 works really well. How about we'll try that? So I'm going to erase this so I have a little more room. So let's try 0. So I got 13 plus 0 instead of x is greater than or equal to 5 minus 3 times 0. All right, let's try it. So I got 13 plus 0 is 13. It's greater than or equal to 5 minus 3 times 0. 5 minus, well, that's 0. I get 13 is greater than or equal to 5. Is that a true statement? It sure is. 13 is greater than 5. So this is true. So with an inequality, what it says to me is I can get more than one solution to this inequality right here. X can be any number that is bigger than or equal to negative 2. Okay? So that's how inequalities work. And I'm going to show you in another video how to graph the inequality because that's one of the other big features of inequalities that differs from equations. Okay? So solve inequalities just like you would solve normal equations. Here's one more thing that I should mention. There's a really big rule with inequalities, and that's different from equations. Now, when you're solving equations, you add or subtract to both sides. You multiply or divide on both sides. We do that with inequalities as well. But there's one thing you got to be careful of. When you multiply or divide by a negative number, it can change the meaning of the inequality. So we have to flip the sign to preserve that meaning. Let me show you a very simple example. So let's say we have something like negative 2x is greater than or equal to 5. Okay? So watch what happens when I just continue solving like normal expression. So I divide by negative 2. Okay? Now I know this is a little taboo, but I am going to change this number because I know the result is not going to be nice. I'm going to change it to 6. Don't do that on your homework. It would be nice if you could do it on your homework. Just change the numbers however you want, right? Anyway, so divide both sides by negative 2. This would get me 1, so x is 1. Watch what happens when I don't flip the signs. Okay, so x is greater than or equal to negative 3. So 6 divided by negative 2 is negative 3. So for this equation, for this inequality, that I had initially, for this very first one, it says that any value of x that's bigger than or equal to negative 3 is going to give me a true statement up here. So let's test that theory. Let's pick 0, because I like 0. 0 is nice. All right, so let's pick 0. So if I have, let's do a different color. I have negative 2 times 0 is greater than or equal to 6. This equals 0. Is 0 greater than or equal to 6? 0 is less than 6. If I have 0 and you have 6, I have less than you. That is not a true statement. Okay? So something's wrong. I chose a number that was bigger than negative 3, but I got a false statement when I plugged it in. So this is where that golden rule comes in. once we divide or multiply by a negative number, we have to flip that inequality sign. So this should not say x is greater than or equal to negative 3, but instead we need to flip it. So it says x is less than or equal to negative 3. We don't have to change the equal to portion. We just change that. Now, if I pick a number that's less than or equal to negative 3, for instance, let's say negative 5. Negative 2 times negative 5 is less than, or excuse me, I'm just going by what's up here, is greater than or equal to 6. Let's see what happens. Negative 2 times negative 5 is positive 10. Is that greater than or equal to 6? Yeah, if I have 10 and you got 6, then I got more than you. So this is true. So flipping that sign made a big difference. So just be careful. This is the only time you really have to worry about flipping the sign. There is one more, but it's only if you're going to do something that you haven't really learned how to do yet. So don't even worry about it. It's going to help you out. I hope this clarifies things, and I hope it enables you to solve inequalities.